Okay, good morning class. So today we'll be solving a numerical on normal shift. Okay, this numerical has been taken from your NCERT textbook exercise questions, which is question number 69.16. Okay, let us first read the question. A small pin fixed on a tabletop is viewed from above from a distance of 50 centimeter. By what distance would the pin appear to be raised if it is viewed from the same point through a 15 centimeter thick glass slab held parallel to the table? Refractive index of the glass is 1.5. Thus the slab depends upon the location of the slab. Okay, so after you have read the question, now try to understand the question. In the question, what they have said, that your pin is lying on the table. Your pin is lying on the table. Let us suppose this is my table. This pin is lying on the table. Now, at what distance the pin is seen from the above the surface of the table? At a distance of 50 centimeters. So I want you to underline 50 centimeter. So at what distance the pin will be seen above the table surface? 50 centimeter. Now read the next part of the question. By what distance would the pin appear to be raised if it is viewed from the same point through a 15 centimeter thick glass slab? Now in this part, what they have done, they have introduced the glass slab. And if they have introduced the glass slab, they have asked by how much distance the pin will appear to be raised. Means, suppose if they have introduced a glass slab of how much? 15 centimeters. So I want you to underline 15 centimeter. If they have introduced a glass slab of 15 centimeter, the question is by what distance the pin will appear to be raised. Now how is it possible? This is possible because of your practical application of refraction, as we have already discussed in that previous topic. What did we discuss? This is a beaker of the water. This is filled with the water. The object was lying at the bottom. This was known as your real depth. Clear? But was the object seen here? No, it was seen somewhere here at a distance which is known as your apparent depth. So in this question and this topic, they are quite similar, right? What is happening? The image of the pin appears to be raised. In this case also, after introducing a glass slab, the image of the pin appears to be raised. Clear? So what they have asked you to find out, they have asked you to find out by how much distance this glass slab, or by how much distance this pin has appeared to be raised. Okay, to find out the distance by which it has appears to be raised, what we did in our topic, we knew our real depth, we know our apparent depth. So to find out the distance by which it was raised, we subtracted the apparent depth from the real depth. Clear? So the distance by which the pin appears to be raised equals to, let us say the distance by which the pin appears to be raised, we say d. Let us denote this distance by d. The distance by which the pin appears to be raised equals to, what was it? Real depth minus my apparent depth. Okay, now from our practical applications of refraction, we remember the formula. What was the formula? We know that our apparent depth can be written as your real depth divided by your refractive index mu. This is the formula which we had derived in the practical application of refraction. If you have confusion, go back to the practical application of refraction and revise. So, instead of apparent depth, can I write it like this? Real depth minus real depth divided by my refractive index. Now real depth, I can take it common. So I have real depth, and inside the bracket I have 1 minus 1 by mu. Now in this case, what is my real depth? The real depth means the thickness of the glass slab. What is the thickness of the glass slab? It is 15 centimeter. So the real depth is how much? 15 centimeter into 1 minus 1 by mu. What is your mu? Mu is your refractive index. Now in the question they have already given how much is the value of the refractive index. The refractive index of the glass slab is 1.5. So underline 1.5. So if the refractive index of the given glass slab is 1.5, I will substitute the value here, 1 minus 1, 1.5. Clear? Now let's do the calculation. Okay, here you can take the LCM. So this one will become 1.5 minus 1, 0.5. Okay, 0.5 divided by 1.5 equals to 1 by 3. 1 by 3 divided by 15 equals to 5 centimeter. Okay, those who have confusion, first let's take the LCM. 1.5 minus 1 divided by 1.5. Clear? What is 1.5 minus 1? It is 0.5. So 15 divided by 0.5 into 1.5. Now 0.5 divide, this one will give me how much? This one will give me 3. So 15 divided by 3 is how much? 5 centimeter. So what does this 5 centimeter means? This 5 centimeter means the distance by which the pins appears to be raised. So earlier it was seen at a distance of how much? 50 centimeter. But now it will be seen at a distance of how much? 45 centimeter. Is that clear? Okay. Now, what is the final part of the question? Does the slab depends upon the location of the slab, or does the answer, correct this one to answer. Okay, does the answer depends on the location of the slab? Means if I put the glass slab here or if I put the glass slab here, will there be any difference? The answer will be no. Wherever I'll put my glass slab, it doesn't matter. Wherever I'll put my glass slab, there will be a raise of how much? 5 centimeter. So in your conclusion statement, what you will write down? You'll write down the answer does not depends on the location of glass slab. Clear? So if you have any confusion, I want you to see this video again, and if you still have confusion, you can ask me directly. Okay, so that's it for today's class. Thank you.